Hi folks, this is page 56, number 2C. So they ask us to find the slope of the tangent of this function at the point 4 2/3. Okay, now one issue we have is that we don't have the tools yet for determining the derivative of this function using derivative rules. Okay, so we're going to have to use the limit definition. Now because I don't want to confuse this h with the h in my my derivative formula, okay, I'm going to say here let f at x be equal to h at x. Oops, there we go. Just so that I don't have any confusion there. Okay, now one thing we could do is we could find the derivative function and then input x equals 4 to get the derivative at that point, or we can just find the derivative at that point directly. Okay, so I think that's what I'm going to do. So what I'm looking for is f prime at 4, and that's defined as the limit as h approaches 0 of f at 4 plus h minus f at 4 over h. Okay, so this represents the derivative specifically at the value x equals 4. Okay, so let me go ahead and do this here. So here we've got 4 plus h into this here, so we've got 2 over square root of 4 plus h. So wherever I see an x, I got to replace that by 4 plus h. Okay, and then the plus 5 minus, now they've given me the y value at 4 already. If you want to check it, you can. So if I stick in x equals 4, I get 9, so 2 over the square root of 9, which is 2/3, okay, which they already gave me. Okay, and all over h. So now I've got to try to solve this here. Okay, so as soon as I see a square root, I should be thinking of using the of somehow using a conjugate, but I have to first start by rewriting this as a single fraction. So I'm going to subtract this using common denominator. Okay, so we got limit as h approaches 0, so this just becomes 2 times 3 is 6, minus 2 times square root of, and I'll simplify this, it's just 4 plus 5 is 9, so h plus 9. Okay, all over 3 times square root of h plus 9. Okay, all over h. Okay, so now I can carry this h into the denominator up here. Okay, so we've got 6 minus 2 times square root of h plus 9 over 3h square root of h plus 9. Okay, and now in order to free this up, this is where I'm now going to multiply numerator and denominator by the conjugate. So 6 plus 2 times square root of h plus 9. And same thing in the denominator. Okay, so notice I had to first write the numerator as a single fraction. Okay, so now let's go ahead, and here this gives us what we want, which is to get rid of the square root. So this becomes 36, okay, minus, and this is going to be 2 times 2 is 4, and the square root of h plus 9 squared is just going to be h plus 9. Okay, and in the denominator, we've got this big thing here, 3h square root of h plus 9, okay, times 6 plus 2 times the square root of h plus 9. Okay, and here some nice stuff is going to happen in the numerator because I've got, here, let me actually write it out. I'll write out this step. Okay, so this is minus 4h minus 36. Okay, lots of writing, but that's how these things are, and the 36's cancel out. Okay, and then here the h, which remains, cancels out with the h in the denominator. Okay, so now that I've gotten rid of this h in the denominator, I can actually take the limit. Okay, so here I got the limit as h approaches 0, and so in the numerator, all I'm left with is the negative 4. Okay, and the denominator here, I've got this 3, and I've got 0 plus 9, so this is going to be again square root of 9, which is another 3. Okay, and here I've got 6 plus 2 times, and again 0 plus 9, 3, square root of 9 is 3. So here, let's see if this simplifies at all. So here, what do we have? We got negative 4 over 9 times 6 plus 6 is 12. Okay, so here I can reduce that as 1 over 3, and it looks like at the end we're left with negative 1 over 9 times 3 if it's 27. Okay, and there's our final answer. Quite a bit of algebra on this one here, but just to recap, here they want us to determine the slope of the tangent at this point, but this function is not easy to differentiate using the tools that we have. In fact, it's impossible to differentiate using the tools we have at this point, so that's why I had to go to the limit definition. And because I only needed the slope of the tangent at this one value, that's why I determined the derivative at a point as opposed to the derivative function.